What are C++ segmentation fault Heisenbugs, and how do they work? Imagine working on a C++ program that crashes unexpectedly, but when you try to debug it, the crash seems to vanish. That mysterious behavior is what we call a Heisenbug. Today, we're going to explore how these bugs, especially those involving segmentation faults, can be so tricky to pin down. A segmentation fault in C++ happens when your program tries to access memory it shouldn't. This could be because of dereferencing a null or invalid pointer, accessing array elements outside their bounds, or trying to write to read-only memory. When this happens, the operating system steps in and terminates your program immediately to prevent damage or security issues. Now, a Heisenbug is a bug that changes or disappears when you try to observe it. When a segmentation fault behaves like a Heisenbug, it can be very frustrating. The fault might only happen under certain conditions or only when you run the program normally. But when you run the same code under a debugger or add extra logging, the crash might not happen at all. So how do these bugs work? Well, many segmentation faults come from undefined behavior. For example, using a pointer that was never initialized, or a buffer overrun where you write past the end of an array. Because the C++ standard allows some behaviors to be undefined, the program might crash sometimes, run incorrectly at other times, or even seem to work fine during debugging. Running your program under debugging tools like Valgrind or AddressSanitizer can change how memory is laid out or how the program runs. This can hide the fault temporarily because memory might be initialized differently or the order of operations may shift. This is why the bug appears inconsistent. Heisenbugs are especially hard to reproduce because they depend on subtle factors like compiler optimizations, thread timing, or memory layout. Sometimes the bug only shows up with specific input data or under certain system conditions. It's like trying to catch a shadow that keeps moving just out of reach. Common causes in C++ include accessing pointers that are invalid, using objects after they've been destroyed, or writing past the end of an array. Race conditions in multithreaded programs can also trigger segmentation faults that behave unpredictably. To debug these issues, start by compiling with debugging symbols and no optimization. Use tools like Valgrind or AddressSanitizer to find memory misuse. Create minimal examples to isolate the problem. Review your code carefully to check pointer and memory management. Adding assertions or logging can help narrow down where the invalid memory access occurs. Understanding how segmentation fault Heisenbugs work is key to fixing them. Recognize that they may not always show up the same way, and use the right tools and techniques to track down the root cause. With patience and careful debugging, you can tame these elusive bugs and make your C++ programs more stable.